Back to it, the real grind. I hate vacations. I hate getting thrown off schedule, but it's fine. Well, it's not fine, but maybe it is. I'm not sure. I'm trying to figure it out. Excuse me. Oops. Glasses are almost good. Been eating French toast recently. I just got an order of groceries. Cook some dinner up, some good old French toast, some of that lost bread. Cool. Good enough. I think my strat's gonna be in like 3 months. I might just start applying to C++ jobs in general. And then that's once I'm done with this, or I guess in 2 months. And then I'm gonna start applying for game dev jobs after, or maybe somewhere during, but ideally after the 6 months of building useful stuff and learning what I really need. Okay, let's get music going. I've been in a music mode for a few days. I don't know why YouTube was blue there just now. Oh. Found some good music recently. No. Cool. Cool. Back to object-oriented programming. Oh, and that was here where we made a procedural versus an object-oriented approach. So we could have something like and even object-oriented it involves enums. So like for example, we could have, I like this card example because it's a game I want to make. Where we have, I mean, what do we represent cards with? I guess we need an enum class. Yeah, that makes sense. We just don't have a grouping class object. Well, sure, we'll just do that. And I mean, I guess we could nest it, right? Can I do that? No, I guess I can't, huh? Yeah, that makes sense. A struct can have an enum, and a struct can have other structs, but an enum can't have an enum in it. What happens if I did try? If I tried though? Yeah, I can't. Wait, that was way faster than I expected. All right. Hand. Well, a hand doesn't have. So we don't need a hand here. We need, what is happening? Oh, I need control as well. Enum class card. And it could be king, queen, jack, ace, joker. But then we have player one, card one. Or what we have, card, player one, card one, king. And then card, player one, card two. And it's queen. And then whatever else. And these are enum classes, so this isn't in scope right now, so we actually need to do card king. And then card queen. And then if I wanted to do something, I wanted to like shuffle the cards. And we'll print them after. So we could say and we'll do references. I mean, we don't really need to because these are technically integers, but it's fine. We'll do a card. And really, I would need to do another here. Whatever. I know how to do this. It's fine. Basically, we would include a string view. We would have a function that converts an enum value to a string value. And then we have print cards. We can pass in some cards. and then we could have like a shuffle version. And what it would do is it would take the first card and set it equal to the second card, and the second set it equal to the first. We could either do like a standard swap if that's a thing that works for the algorithm header, or if it doesn't work, there's no if it's not a template, then what we could do, or if it's not prepared to use an enum, what we could do is we could just make a little intermediate variable. So we would have like another one, we could just say card temp, whatever, nothing. And then we could say, actually, and we would just initialize it with player one, card one. And then we could say player one, card two is, or actually we would say player one, card one is now player one, card two. Oops. And then player one, card two is now player one, or is now temp. And then boom, they've been swapped. So we would have a function to swap them. This is having an issue because there's no statement inside the no, it's actually my include statement. Yeah, because we can have a blank function, so it's fine. So yeah, I would have a function to call to get a name here, but if I wanted to print it, then I would have to call print cards and pass in player one, card one, player one, card two, player one, card two, 3, 4, 5, instead of just saying struct hand, and then we could have enum card, king, queen, jack, joker, ace, and then it has card one, or card one, king, and then card two, queen, or we just say you start with a blank hand and you have to draw cards, and then we could have a function that gets a random 5 cards and assigns them, and it's just called draw cards. You know, I'm gonna make that really quick. No, I won't, because I'm gonna have to do immerse and twister, and I don't feel like doing random number stuff right now. Card 5, cool, that's the hand. And then what we could do, do I want to do that? I mean, I could, right? Fuck it, I may as well, right? I mean, I'll make some real stuff real fast. Let's get random. Need immerse and twister. Let's get include chrono. Okay, and so we'll have this, and then we can just create a little hand, right? We'll just create hand, player one hand, or we could just say player one if player one only needs a hand. And then we could technically say there's a struct called player, and it's called is playing or is not, whatever the hell. We'll just call it player one hand. Sure, that's fine. It's not crazy. And we could leave it as empty values. Let's do a. Let's just teach standard character output, right? So let's get that really quick. Okay. Nope, we'll do no stream reference, operator insertion, return an OStream reference, and well, it takes an OStream reference and it takes a hand reference. This OStream reference needs to be named. We're just gonna call it output device, and then hand, and what it'll do is it'll say, excuse me. Oh, and actually what we need to do is teach so that we can output card. And maybe we want this in this structure, but for now I'm just gonna do operator insertion, standard OStream reference, output device, and we're gonna do the same thing here, and instead this time it's going to take a hand, because card doesn't exist here. So hand card, and it will be, yeah, we're gonna get string. So we actually also need string view here. So we're gonna do Okay, so we're gonna do output, or we're gonna say, well, I guess do we call it for each one? Right? We still need to get the value, so I guess we do that. All right, so we'll do standard string view, get card or card as string, and it takes a hand card, and then we do using hand card, and this is using, well, actually, does this work? Enum, because card is the enum, and then we're going to switch on card, and we're going to say case king, return king, case queen, return queen, case jack, return jack, case joker, return joker, case ace, return ace, default, return question mark. Cool. Okay, and when we're going to print a card, we just do output device, and we're going to output to it. We're passing to it card as string card, and that's it. And then return output device. And then here, what we're going to do in the hand is we're going to say hand dot, yeah, cool. All right, this will work. So we're going to say output device hand dot card one. Well, we're going to say card one, hand dot card one, card two, hand dot card two, card three, hand dot card three, card four, hand dot card four, card five, hand dot card five, and yeah, sure, might as well end the line after, right? And then return output device. Okie doke. And then we're gonna say void draw cards, and it takes a hand. It takes a hand reference hand. And what this is gonna do is we could create the Merson Twister elsewhere and then just call it here. We could say get random card. We could say card one is this, card two is this. I don't know how to return and initialize a list, but that would be cool if I could just get the cards to do it instead of like having to pass this. Let's say we pass this, and what it's going to do is it's going to find all the cards and then set them here. We could say card get random card, and it doesn't take any parameters, and what it does is it makes, do we call that here? I'm not sure. Let's go ahead and just make a stat. I could have made these in different files, but it's fine. We're gonna do a static standard. What do I want to do? Static standard Merson Twister 19937 called card empty. And actually what we're gonna do is we're gonna say, and actually we shouldn't do it like that. We should just initialize it like this. What is this? What is happening here? Okay, it doesn't have any issues, just bugging. Maybe not. What's not referenced? Hand here? That's okay. Well, that's not gonna help. What we're gonna do is we're gonna initialize this guy. So we're gonna need to do, we're gonna return, what are we returning? We're returning a standard, Merson Twister called seed card empty. Doesn't take anything. And what we're gonna do is we're gonna create a random device and call it rand, and initialize it with nothing. We're going to create a standard chrono. Well, actually, what we're going to do is we're going to do a standard seed sequence. That's also what we needed this for. And standard seed sequence. Standard seed sequence called card seeder or card empty seeder. And we're going to initialize it with, it doesn't have to be anything, but we're going to do standard, actually we're going to do static cast to a standard Merson Twister 109 through 7 result type, right? That's the type. And what we're passing it is standard chrono steady clock time, or hold on. Now dot time since last epoch dot count. And so what's happening is it's getting this time. Yeah, that's fine. We haven't used this yet. So we're getting the time since the last measurement of time, which is some random-ish number. Because if we did it a while ago, well then we've know it, like the value is changing right now. It's changing. There's not really a way to know what it is without having like a clock. So it's going to have one little seed value that is a little piece of time, which is cool. And then another, I'm just going to space this out. Another is going to be rand, 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 another is going to be rand. I think that's 7. 4 plus 3, yes, 7. Cool, so we've seeded the seed sequence, still haven't used hands, so that's fine here. And what this is going to do is it's going to return a standard Merson Twister that's temporary. And actually, sorry. I guess. And it's going to be initialized with card empty seeder. I think that's the point here. And did I create one? Did I call? Yeah, and so we just seed card empty here. Seeded once at runtime. And then we're gonna say, here it is, card get random card. Okay. What we're gonna do is we're gonna call we're gonna have a switch. Well, not yet. We're gonna just call card empty. Or we're gonna say int card choice, and it's going to be card empty called to get a random number. Random number from PRNG card empty. Okay, and we're gonna switch on card choice. And also here we're gonna say using hand card. And this is an enum, so we're using enum, not a namespace. Oh, and then we'll just say case. Oh, and actually get random card needs to be get random number. So this actually needs to be int get random num, get random int. And what this is going to be is return, excuse me, a standard uniform int distribution, and it's calling card empty. And it is initialized with the values 0 to 4. And this is actually called card empty. Oops, don't need F here. Cool. Random integer from card empty. PNG. Okay, and so what we're gonna do is not call card empty. We're gonna call get random int. And actually, what we're gonna do is we're not gonna necessarily. This is going to take an int min int max, and this is gonna be min max, and then we're just gonna call get random int with 0 and 4, and we could say. Do we say minimum card value to max? I don't want to pass king and queen because then you're wondering why. I don't want these to be magic. Let me get the fan on real fast. I mean, I could have a namespace with some static, but int minimum card value, sure, 0. And then int max card value is 4, sure, okay. 5 cards total. And maybe we start at, I mean, sure, it's fine. I mean, do we do 1 through 5? Maybe that makes more sense. I think it's more idiomatic, honestly. Doesn't really matter to me. And this should be min card value. And then this should be max card value. And now we can do case 1. Return king, queen, jack, king. Case 2, return queen. Case 3, return jack. Oops. Case 4, return joker. Case 5, return ace. And then default, return. Well, we have to return a card, so. It's the fun part here. What happens if I do nothing? I'm pretty sure I can't. Oh, I actually can? Maybe that's fine. Because this is the only possible ones. If somehow the value is weird, then, I mean, I could make a weird default value, I guess. But I don't really want to. I mean, do we want that? We could say invalid. Invalid card. And then that way, if we are printing it and it's not these guys, it's going to hit invalid card and it'll print nothing. And then we could say default return invalid card, right? Something like that. And now we could say draw card. So what we're going to do is we're going to pass in a hand and we're going to say hand dot card 1 is get random card. Hand dot card 2 is get random card. Oh, actually, is there a way to just iterate this for something? This card, I don't know how to make it so that we're doing a different card. Hand dot card, like I can't do hand dot card X and then replace X with 0, 1, 2, 3, 4 or 1, 2, 3, 4, 5 for the cards. I guess I'll do this for now, just to keep moving, and then I'll figure out if there's a better way of doing it. Cool, and now we could say draw cards, player 1 hand. And now I could say, I could just output the cards. Instead of saying print hand, I could just output it. But maybe we don't really want to do that. Maybe. And maybe we have a struct and it's player and it has the name and then the hand and then we do that, but I'm just gonna do this, it's fine. And I think this actually does it at the end anyways. So, but because I'm using it in the context of standard character output, I'm gonna do this. That way I can chain it. Oops. Card 3, Y, card 3, space. There it is. I didn't compile there, but queen, joker, jack, joker, jack, jack, queen. Holy shit. Joker, king, king, jack, king. King, 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 queen, jack. Queen, ace, jack, joker, ace. Joker, jack, jack, queen. Joker, joker, jack, jack, jack. There's a lot of threes in here. Jack, jack. Is the seating okay? It almost doesn't feel random, but I mean, maybe only 5 options. I mean, how unlikely is it really? Yeah, I mean, sure. Cool, so now we get random hands of cards whenever we start the game. Cool, okay. And the point here is that now we could say, and if I wanted, I could make a player, struct, and I could define these all together. Player, and we put all of these inside here. I knew there was an extra space. And the player has a hand. And, I mean, we could say hand. Uh-oh. Oh, hold on. Well, now everything is going to have an issue. Hold. I don't know what the issues are right now. Hold on. 30? Oh, it's having an issue here. There it is. Because it was thinking that everything was like in the definition of the struct here. Okay, that worked. That wasn't too terrible. And so it has a hand. It has... And then it has a standard string name. And then it has a bool is playing. Or is in play. Or is playing. Something like that. And so what we could actually do is create... We could just create a player that has a name and a hand. A name is playing in a hand. Excuse me. Player Ethan, and I am Ethan. I am playing, and my hand is nothing. And then in this case, we're gonna say Ethan dot hand. And in this case, it's gonna be Ethan dot hand. And I suppose I don't even need to do that. I could just leave it so that the hand is blank, but I kind of like doing that. So we could say nothing. And if I wanted to, we could do dot name and then put it in brackets, but I don't know. It feels like it's kind of dirtying in the waters a little bit. And then here now we could say, and these members could all be inside the player too now. because the player is the one who's reading his own cards. It's not like, hey, someone else read for me, please. So, card empty. And let's just say we actually pass player. Can I do player.hand that card? Oh shit, you can. And it takes me now, because I'm the player. And then we can say... Okay. Oh, and we could say... And really, we would want this to be... We wouldn't want to do it like this. At this point, we would want this to be a different function. So we would want this to be called... this is fine. We could say... void print cards. And in this case, it would say if player dot is... Oops. Player dot is playing... Then... Else player.name is out of play. Or we could just say is not playing. And now we could just do or we could say print hand. Cool. God damn, 4 aces. Is this seed just terrible? I don't know. The MT ain't it. Oh, wait. But it was seeded one time, static. We're not calling seed card MT any other times. We're only calling card MT. So it should be fine. And it's static, so it's not like the values are resetting. And we're not getting the same values, we're just getting some repeated shit. But I guess that's fine. I mean, it'd be weird if it was 1, 2, 3, 4, 5. Oh, and actually, really, this is how this should be going now. Now this should just be Ethan.drawCards. Ethan.printHand. And now we just have to fix stuff. Oh, and actually this should be, I don't have to, there shouldn't be any parameters here anymore. So this should just be hand. So this part is fine. It's only having an issue here. This should now just be if is playing. And this should just be removing dot player. I'm not sure what the current issue is yet. This is interesting. Get random card. Ah, so this should be... This is where we would have them included elsewhere. And then, but here we could just forward declare. So we'll just do get random card. That's the hard part, because this is supposed to be a forward declaration here. This is the return type, but it hasn't seen the definition yet. I mean, it could just define it earlier. That might be what has to happen here. Because I can't forward declare this because these things are defined after. Fuck, I can't even... This struct should just be defined somewhere else, really. Oh. Yeah, that was cool. It was because I was calling the identifier, not the actual function. I forget that you have to do .draw cards like that. But I should have remembered though, because that's the same thing in the seeding. Excuse me. Now, what if we do this, though? It's not recognizing it. Does it mean that I have to do that inside? It needs to be before here to be called here, or to be called later. It needs to be defined or at least seen in here. Why is the linker complaining? I mean, do I just have to define it in there? I mean, maybe I do. But now I have to put fucking everything in there. But then maybe I can forward declare that guy. So we'll see. Yeah, see? And so this one doesn't know to get random int. And so now how about we put this guy up here, huh? How about fucking time? Oh, yo, yo, yo. What the fuck is happening here? Oh my fucking god. Wait, why? Print hand. Hand dot card one. Oh my god, character output hasn't been taught how to print it yet. Oh my. What? I mean, this probably isn't enough. And it doesn't know that cards exist. So do I have to teach it inside the struct? I don't know if I can. Fuck. It's just not being taught yet. It hasn't been taught. It doesn't know how to print it. It's just gonna print integers. I mean, I guess we could put these in hands. What would happen if we... Doesn't want to be in there. Oh! Wait, hold on. Yeah, because this is printing a card. This is a player's hands card. Like, I don't... Do I just call this function every time? I guess. I mean, do I just return the string? Wait, hold on. Wait, why do I need to do this? Wait, if I'm using standard character output and a card next to it, I'm teaching it to print that card. Oh, so I could either pass it a string or pass it the card. The point is I want to pass it the card. Like, why isn't this okay? Motherfucker, it has two, bitch ass. Oh, wait, hold. No, this is a reference still. Why? We can't teach it inside a struct? I guess not. Okay, fine, fuck off. Wait, can't I just get the card as a string? Yeah, fuck it. We don't need that anymore. There it is. And then we could do like one header file that has a player, and then we could have another one that has the random card shit. Alright, that's cool. Previous chapter we covered structs. Okay, cool. What do we do? Hold. Where were we at? Of course, why did my fucking retarded ass not put where I was? Alright, some invariants. Oh, here we go. Oh yeah, I was saying that we would need an automatic way to make first initial, get the first character and name. So, compared to numerator and denominator, where, okay, obviously the denominator can't be 0. Well, in this case, the denominator, or well, the invariant, rather, the one that can't be something, the one that must always be true in order for the object to be in a valid state, it can only be the character it can only be the first character of name. That's it. It should always be the first. So it's very easy for it to become false, the invariant, for it to be invalid. Excuse me. Yeah, if someone later on is using an employee and the name gets changed, or the employee is then assigned to be someone else, they might assign the employee, they might think that the employee only has a name. And so what they do is they say, hey, employee is Jared. All right, well, now this employee object is going to refer to Michael because Jared quit. So now there's a new one and we assign it to be Michael. Well, we haven't updated first initial. If we just assign it to be Michael, it's going to leave first initial as is. So they're going to need to have to go in and put M for first initial. But it's going to say J. So if they don't remember to put in the first initial, M, then it's going to be invalid. Because it'll say, hey, first initial of the name is J, but it's really M. What's going on here? Or rather, name is Michael, but first initial is J. Why? Yeah, if we make functions, the functions don't just get used automatically. The user has to, the actual programmer has to use them. Yeah, stop. So we need to stop relying on the user. So we need classes. Apparently classes are going to help us maintain the invariant, and it's what is built in. Like I've seen public, private, and protected types of data members, and that somehow affects their visibility somewhere else. I'm not sure if it's like linkage where it's different files, or if something else has to have some sort of access to be able to use it. I don't know. I don't know how that works. If it has to be a child maybe and nothing else can see. So if you're a child, or if literally there's a class called, well, if you're a class called kid, and kid is a subclass of parent, it's a child of parent, it's inherited or it inherits parent, then maybe private things are only accessible to things within that given class. Nothing else can see or access the values of them. And the harmony in this song is amazing. It either can be put invalid, meaning that the constructor, when we create the variable or the object or initialize it value, it forces us to give it valid values, maybe. Just like an integer can't be assigned on a string, we could have a user-defined type not able to be assigned invalid but still valid things. You know what I mean? Like a valid character, but it's not valid for this object, class object. Classes apparently do. Bjorn Straustrup. I think structs are already pretty intuitive, but maybe there are improvements in classes. I don't know. Okay. Simula. A class. Almost identical. We use them differently. Data hiding. Encapsulation meaning getters and setters. Like if it's private, it can't be given anywhere else, but we can have some public function. Oh, so we have private data members, and then we have public variables that return, or public functions that return those. And you could save the invariant by maybe, I guess what we would do is we could say, hey, you can't access the invariant, you can't change it, it automatically updates. Because it's needed, maybe. Maybe we always need the initial somewhere. But you can't change the initial for someone. You can't change the first character in the name. It's just, it is what it is. You can change the name from Jacob to frickin' to Ethan, right? But you can't change the character, the first initial from E. It's stuck E because the name is Ethan. It's private. You can't touch it. You can try and you can use functions to do it maybe, but I guess this is extra protection. The member variables of a class are M, huh? Maybe so it's obvious whether it's public or private? I'm not sure. Okay. Whoa, public. Okay. So we could do class dog, and the dog has int num legs. That's what it has. It has what else does it have? I don't know, something else. Boom. Public. Fuck. Named wrong. Often, meaning that maybe there are some that aren't. Public versus private, protected something. Maybe some that we never touch, might as well be as convenient as possible. But maybe you would think it would be the ones that we do touch that are as convenient, but maybe not. Most of the library is classes. Well, yeah, standard character. Yeah, exactly. Oh yeah, because standard character output is an object of a class, and it's a standard basic string, I think. Given some set of values, ages, address numbers, etc., might want to know what the minimum and maximum are. Since the minimum and maximum are related, we can do this. However, as written, isn't it just if the max is lower than the minimum? If the max is less than or equal to the minimum? Well, I guess the invariant, so it's same thing. So it's if the max is less than or equal to, that means the invariant is false. I just said it in the inverse. So we say that the invariant, the true condition, what needs to be happening, meaning that the invariant for a quotient is that the denominator is not 0. The false condition of the invariant is that it is 0. I said that the invariant, but really I meant that the false version of the invariant is when the max is less than or equal to minimum. So really the invariant is when minimum is greater than or equal to the maximum. Maybe equal to is okay, because if there's only one number, then it's fine. So I think really the issue is just when the minimum is actually greater than the maximum. So really the invariant is that the minimum needs to be less than the maximum. Oh yeah, it needs to be less than or equal to. So the point is that it can't be greater than. Yeah, that makes sense. Cool. I agree. And get back to bookmarking. Lock it back in. Ah, the song is addicting. Nice. This is the one with the good subtitles. Man, this impact is great. There's like a bass in the background. Yep. Member functions. Yeah, but then we have to pass it a date instead of just having it take nothing, and we just do dot print. So we do date dot print. And then we can remove the date dot for each of those three members. Or subparameters almost. In this case, members of the parameter. I hate this part of the song. This fucking staticky voice pisses me off. This sounds really bad. No, this is good. Here it comes. It's 2020. It's fucking October. No. Yeah, October, November, September, October, November, December. Yeah. It's October, and now it's the 16th. 2 days have passed. But now we have to print and pass in the object instead of just saying day dot or today dot print. Yes, and this is what classes are trying to prevent, where we link the properties and behaviors together. Oh, I can't. That note is really high. Oh, nice little guy's voice. I'm fucking ready. Ready to grind. Let's go. Yep. 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 Now we have to fucking resolve the scope of the namespace. Great. Non-member. Okay. What? Must be declared in type. Oh. Declared in the type, but can be defined wherever. And so the point is what? We could have definitions totally separate in other places. So we could have like player functions, and it's all the function definitions, and they're all inside the player. And in the player file, in the header file that we're including everywhere else, that includes the member functions, and it has just all the little declarations. We don't need to know all of what they're doing.
Excuse me. Cool. Yep, exactly. Where, how we're using it in the parameters, let's go. Exactly. Instead of calling the members of a parameter, we're just calling the members of the class that this function is in. That makes sense. Yep. Cool. Yeah, so we can't call print something without having an object, right? We can't have a ball and a function called throw, or we can't call throw that's a member function of a ball of the ball class without a ball. We can't just call throw. We gotta call ball.throw. Cool. Implicitly passed. Nice. The implicit object. The object that the member function is a part of. Or is being called on because that object is being passed to it. That makes sense because we could have two different objects and we call the function, and in each function, the object that the function is being called on is implicitly passed to the function because the function can access it and its members. The this pointer, huh? The pointer to So the class in the function, there's like a hidden parameter and it's this, and this is the object that's owning it. Yep. Any member identifier not prefixed with the member selection operator is associated with the implicit object, meaning that we can use the implicit object's member data members in member functions and methods. Excuse me. I gotcha. So we're saying Joe and Kate. Yeah, that makes sense, right? So we have the name and the age, and we're saying Joe dot kisses, and then we're passing it the person that the function is operating on is taking as a parameter, and so it'll say this person's name kisses that person's dot name because we have to access that object because that's not the object that this member function is being called on. It's just one that it's receiving as an argument into a parameter to initialize its parameter. Yup. And so we can do dot name to refer to the explicit object, the one that's being passed explicitly. That's why earlier when I left them as is, as person dot whatever, it wasn't associating with the object, and it was like, hey, whose name are we using here? Which dog's legs? Who? What's happening? Whose cards? Excuse me. Yeah, it reads way, way better. It indicates what's happening and who's doing it. Yep. Which is the effector and which is the affectee or affected. Sorry. Yep. Yeah. Putting them in a header file and then including something like that. But in the header file, well, yeah, that's the strat really. So we could have functions here. We could have actual functions z, x, m, and then in m data and y. And we can return m data, which hasn't even been seen yet, in z. We can call y from x. We can call, okay. Interesting. Oh, meaning that, yeah, we have a foo, and m data is actually initialized with y, 5 in this case. I would imagine you'd want properties first, but maybe not. Gotcha. So if we have x, and x is initialized with y, but y hasn't been initialized yet, then it's undefined. Okay. Yeah, we're touching memory. We haven't. Yeah, makes sense. We don't know what's there yet. But if we're in default initializing a guy and we always know what the value is going to be, then maybe okay. Like initializing embed with m data doesn't work because we haven't seen m data yet. And it's because m data is something that also needs to be initialized. We also can't initialize that because embed m data hasn't been initialized yet. Yeah, I would agree there. Oh, okay, that's nice. It just creates a little nice for declaration. Nice. Oh. And the point is that if we have a function defined in the beginning, and then we have a bunch of members defined later, and those are used in that function, and we call the function, the compiler will say, what's up? But what it does to remedy this is it for declares the function in the definition, and then places the definition after the class definition, and then it will see all the members, compile, and then compile the definitions of the member functions. Cool. So it's C struct foo. What it's going to do is say, hey, we got 3 functions and then M data. What we're going to do is we're going to do 3 for declarations. I'm going to look at M data, and then we're going to define Z, X, and Y, which are those 3 member functions. So now the compiler has seen all those. M data exists, and now Z can return M data. X can call Z, or sorry, X can call Y, and Z is cool, which it already was. Member oh, are you kidding me? Member functions can be overloaded. Oh, member functions can be overloaded. Oh shit. Alright, I guess we'll see that tomorrow. Okay. Guess I'm done for now. Self-test soon.